Hello, good morning. My name is Irvin Daniel Perez de la Cruz. Today I am pleased to present the results of the evaluation of a pesticide based on Momordica Charantia applied using two methodologies in a sample plot of 22 cacao trees. This research was conducted in collaboration with MSCs in Biochemical Engineering Juana Selvan Garcia, MC Pamela Arroyo Falconi, Doctora Nora Alicia Purata Perez, and Doctora Rosa Margarita Hernández Vélez. It is an honor to be part of the International Research Congress, Academia Journals, Puebla, 2025. To begin, let me briefly explain that cacao has been valued for centuries due to its nutritional and cultural richness. From a nutritional perspective, according to the International Cocoa Organization, cacao is one of the richest plant-based foods in antioxidants, and its moderate consumption is associated with health benefits such as reduced blood pressure and improved brain function. In addition, cacao plays a major role in the economy of countries like Cote d'Ivoire, Ghana, Nigeria, and Ecuador, some of the world's leading producers. In Mexico, cacao is essential for rural food security, providing both income and high nutritional value food products, as highlighted by the Food and Agriculture Organization, FAO. However, the presence of pests and diseases such as moniliasis, witch's broom, and cacao thrips make plant health management a critical issue. Moniliasis is one of the main diseases affecting cacao in Mexico, especially in the producing regions of Chiapas and Tabasco. These challenges have prompted the search for sustainable alternatives to synthetic pesticides due to their negative environmental and health effects. In this context, Momordica Charantia has gained attention because it contains triterpenes and flavonoids with documented antifungal and insecticidal properties. Its use as an agricultural bioproduct represents a promising strategy within integrated pest management. The objective of our study was to evaluate its effectiveness as a biological pesticide under real field conditions, comparing two application techniques to determine their adaptability, efficiency, and pest and disease control potential in cacao crops. Tabasco, a región with ideal edapoclimatic conditions for cacao cultivation, including fertile soils, high relative humidity, and stable temperatures. We evaluated a sample plot of 22 cacao trees of the Carmelo 1 variety. These trees were divided into two groups based on the application method. 2 trees were treated using foliar application, spraying directly onto the leaves, while the remaining 20 trees were treated using root application, allowing the extract to be absorbed through the root system. The pesticide was applied over a 6-month production cycle, flowering, fruiting, and harvesting, with increasing doses every 15 days to assess the tree's adaptation and resistance, reflected in their leaves, a key health indicator in trees. As noted by Berg in his study, changes in leaf color, size, shape, and distribution can indicate nutrient deficiencies, pest infestations, or diseases. We also monitor variables such as the initial number of pods, visible disease presence, and the total number of harvested pods. This experimental strategy allowed us to compare the impact of each technique on plant health and productivity. Environmental factors were also recorded to contextualize results and evaluate the adaptability of the biopesticide in real-world field conditions. The first analysis assessed the productivity of the treated trees by comparing the number of healthy pods present at the beginning of the study to those harvested at the end of the cycle. We established that a recovery rate below 30% would be considered inefficient, while a rate above 80% would indicate high treatment efficacy. In trees treated with the foliar method, recovery rates were low and fell below the efficiency threshold. Conversely, trees treated via root application achieved recovery rates above 80% in most cases. This suggests that the extract was absorbed more effectively through the roots, promoting systemic distribution and a stronger physiological response. The comparison revealed that root application enhances bioproduct uptake and significantly improves fruit production. These findings highlight the importance of considering not just the pesticide composition, but also the application route as a critical factor in treatment efficiency. The second analysis focused on plant health, sanitary control. All trees, 100%, initially exhibited disease symptoms, indicating a severe phytosanitary scenario. Over the 6-month treatment period, we tracked the evolution of the trees, particularly the ratio between diseased pods at the start and the pods harvested later. Trees treated via root application showed significant recovery. The ratio between diseased and healthy pods approached 1, suggesting near total recovery of tree health. By contrast, foliar-treated trees failed to reach optimal health levels. Although some improvement was observed, it was insufficient to counteract initial damage. These findings align with those of Garcia et al. 2020 evaluation of Momordica Charantia extracts as a pesticide in cacao, who noted that under high disease incidence, foliar application has limitations. In summary, root application not only boosted productivity, but also achieved more effective disease control, validating its use as a viable tool within an agroecological and sustainable cacao management approach. Photographs taken during the experimental phase are presented below, visually documenting the condition of the plants prior to pesticide application. The images clearly show differences in leaf coloration, fruit shape, and overall tree appearance. In trees treated via root application, there was a noticeable improvement in foliage density, uniform green coloration, and a reduction in visible lesions indicating favorable systemic recovery. The harvested cacao pods exhibited healthier surfaces with fewer signs of infection. On the other hand, trees treated with foliar application showed less consistent improvements. Although some positive changes were observed, they were limited and not widespread. The photographic evidence supports the quantitative data presented in the previous analysis and provides a visually accessible validation for producers. This type of documentation is particularly valuable in rural settings where visual indicators are key to assessing the effectiveness of a technology. In conclusion, the root application method proved to be the most effective both visually and in terms of productivity, establishing itself as a viable organic alternative for cacao crop phytosanitary management. These are the references consulted from which specific information was obtained for the study. Thank you very much.